Calculating the inverse of a matrix by using the Gauss Jordan method. Please be sure to subscribe so you don't miss out on any future videos. An inverse of a matrix can be calculated if the following properties are satisfied. The determinant of the matrix is non-zero. The matrix being evaluated is a square matrix. Let's look at an example. We want to calculate the inverse matrix A. The first step is to write matrix A beside an identity matrix. We must ensure that the identity matrix is the same size as matrix A. Since matrix A is a 3 by 3 matrix, the identity matrix is also a 3 by 3 matrix. Step 2. Perform elementary row operations to reduce matrix A to an identity matrix I. Note, each elementary row operation performed on matrix A must also be performed on the identity matrix. We have 3 row operations available to us. Multiply a row by a constant, interchange 2 rows, or add a multiple of a row to another row. Let's look at this matrix. So we already have a 1 here as a leading entry. We want all the other elements below this 1 to be 0. Therefore, we need this value to be a 1. So we are going to add a multiple of a row to another row. Negative R1 plus R3 leads to this matrix on the right. Now that we have zeros in this column, we move on to the next column. We have a 1 in this column right here. So now we want to try and get 0 values above and below this 1. We have a 0 here, but we want to turn this negative 5 into a 0. Therefore, we're going to add a multiple of a row to another row, 5R2 plus R1. And this leads to this matrix here. Now we need a 1 in this position right here, so we are going to multiply a row by a constant. We're going to multiply row 3 by 1.5, and that leads to this matrix right here. Now we have a 1 along here, and now we need a 0 in these 2 positions. So therefore, we are going to add a multiple of a row to another row, which leads us to this matrix right here. And now we have an identity matrix on the left, and therefore we have the inverse of matrix A. Thank you for watching. Please like, share, and subscribe.